Okay, so we talked about the predictive schedule and agile scheduling. Both are quite different. Predictive scheduling is more organized and we plan everything upfront, whereas agile scheduling is completely different and unique because it plans while it moves. It is actually in action. The work is going on, execution is there while the planning is continuously being done. Hybrid schedule, as you understand, is something in between these two extremes. Therefore, you will find elements of predictive planning at the top of a hybrid schedule, meaning we would create a project management plan, we would create upfront plan, but not as deep as we go in a predictive project. We'll go to the level which is just understandable how the things will move downwards. But at the bottom, we take full advantage of agile working. We work in with agile teams and they work in small iterations. So in a way, we are taking the benefit of both sides, but we are adopting a hybrid or mediocre approach. It is an example of high-end tailoring. You are adjusting according to your need. You are not following any one standard methodology, but you are tailoring it. Such a tailored plan, tailored schedule would be called a hybrid schedule. Naturally, there are benefits of both sides in here, so therefore it is good. Uh, Sorry. Okay. As far as predictive schedule planning is concerned, as we already talked about it, that we have the work packages. We have already broken down in scope uh, the project until the work packages. Now, these work packages are to be further exploded into activities because activities is the level which is to be performed. Once the activities are there, we will create interdependencies amongst the activities. We will establish a precedence relationship, or you can say the sequence in which these activities will have to occur. We also need to develop an estimate for each activity, how much time we need to dedicate for each one of these activities. But you see, at that time, we don't have resources calculated so far because resource management is a separate knowledge area. It might have been going on in parallel, but when we are assigning durations to the activities, we probably do not have a very good idea how many resources will actually be available to do the job. Therefore, we take an approximation and we take average resources and we base our durations on that. That means that in future, when the resources will become available, we may have to adjust our activities or our schedule accordingly. But anyways, this is a good starting point. We may create an idea how the project is going to go on, how much time will it take, what are the problems expected in this schedule, and things like that. Once we have all the activities, their durations estimated, and their precedence established, we put it all together into a network diagram where durations are available. Normally, network diagram is the precedence relationship and it does not show the durations. But when we put duration on top of it, it helps us determine the critical path. If you know about critical path, that is good. But if not, then I'll show you how critical path is determined. Actually, critical path is a very important part in predictive project management because this actually serves to determine how much time this whole project is going to take. Now, duration estimate is quite different from the cost estimate. Because if you have 200 activities and you have estimated the cost of all 200 activities, you can sum it all up and that will give you the total cost of the project, isn't it? But what if you have durations estimates available for every activity? Can you add all the durations to find the total duration of the project? That is my question for you. If you have got 200 activities in your project, you actually know the duration of each activity. Can we add all these durations to find the total duration of the project? Yes or no?
No, no. It
No,
depends
and
if
why not?
each,
Because
because not all are dependent to each other. They can run in parallel or whatever.
exactly that is the point. Because all the activities are not happening in a sequence, right? There are many activities which might be happening in parallel to each other. And therefore, that does the summing up the durations does not actually represent the total duration of the project. Critical path is a method by which we determine, after considering all the parallel activities, we determine actually how much time will be required to complete the project. Once we have that critical path, it is very convenient to convert this critical path data into a schedule, into a Gantt chart. Actually, I must say that without having gone through this whole exercise, nobody can determine a schedule. Gantt chart cannot be developed. You might be amazed at my statement because normally project managers, first thing they create when they are trying to schedule is the Gantt chart. Many of them I have seen do not even create a critical path, do not properly break down the activities, do not consider the dependencies and all. They just create a Gantt chart. That is completely hypothetical. That is completely incorrect. A Gantt chart can only be created when you have done all the jobs which are written up there. Breakdown of the work packages, determination of dependencies, estimation of durations, establishment of critical path. Once the critical path is there, only then you can, for the very first time in your life, see the shape of the Gantt chart. But this shape of the Gantt chart is just a preliminary shape. This is not the final shape. It needs a lot of adjustments in it. And what are those adjustments? As I mentioned, that when I estimated the duration of activities, I did not know exact resource availability. Therefore, those were average or approximate resources on which I calculated the durations, and therefore my critical path is representing that data. But now that I have got actual resource estimates available, I can replace them with those average resources and adjust my critical path, and resultantly my schedule will be revised and refined. You agree with that?
Yeah.
Once we have done that, then we need to do another exercise, and that is to find opportunities within this Gantt chart where we can accelerate processes. That means how can we compress our schedule, right? Maybe we have got gaps. We can try to push activities together and try to reduce the overall duration of the project by a couple of days. That process is called compression of schedule, and we have got certain techniques for that as well. And once we compress the schedule, naturally, schedule will again be amended. And after we have done all the adjustments, this is the final shape of the Gantt chart or the schedule we will get. This is what we must present to our bosses as if this schedule can be approved and baseline. Remember, when this schedule will be baseline, then it is no more in the power of the project manager and his team to make any further amendments all by themselves. They can't do it. Now, it has been baseline. When something has been baseline, the authority to make any changes to that resides with the people who actually created the baseline, who actually approved the baseline. So we can do anything before the baseline, we can make all the adjustments, but once it is baseline, then our planning work as far as schedule is concerned, that has been completed. You remember, even in scope management, when we created the product scope, project scope, scope statement, and then the work breakdown structure, work packages, once all of these things were done, we also baselined the scope. That means even scope, when it was baseline, it could not have been changed by the team without the permission of the sponsors. So there are three baselines in our project, as you understand. One was the scope, second is this schedule, and third is called the cost baseline, which we will talk about a little later. But right now, we are concentrating on the schedule planning, and these are all the steps we need to learn about. You remember the work packages we created, the work breakdown structure? That is our starting point. Why? Because the work packages at the bottom of your work breakdown structure are our starting points. We will have to break down each one of the work packages into certain activities which can be performed to complete the work package. The activity breakdown, it should not be done on the work breakdown structure, but it is the scheduling activity. So we take the WBS and we take each one of the work package and break it down into a couple of activities. Can you answer me? Why can't we break down the activities while we did the scope? It was easy. This was a structure created. Work packages were there. We could have further broken the work packages into activities. Why did we not do that? Yes, Arman?
No, I'm actually thinking why, because in my mind it can be possible. So I'm just thinking, sorry.
Okay, let me give you an example. For example, I'm constructing a house, and there are the work packages in the house are construction of the west wall and construction of the floor of room number 1 and this and that. So these are all various work packages. But do you realize that each work package may have a lot many activities to be done? Like for the construction of wall, I have to procure the equipment and the bricks and the raw material, cement, etc. And then I have to start putting together a structure for that. And then I have to do the plastering. Then I have to do other things. There are a lot many things to be done in the construction of wall. But as far as the project manager is concerned, he is only concerned about the progress of that work package. So whenever he would be noting his progress, he would say, okay, what about that wall? How much that has been constructed? So we will have to cumulatively tell him that that work package is, say, 60% complete or 20% complete, but we don't mention that cementing has been done, plastering has been done, bricklaying has been done. No, these activities are not of much interest to the project manager. These are of the interest to the people who are actually doing it. Therefore, work breakdown structure is designed in such a manner which could efficiently develop a progress reporting mechanism at the higher level. As far as the activities are concerned, they are the lowest level of work which has to be done by the team. Team has to take care of activities. But before the activities could be identified, they have to look at all the work packages and try to break them down into activities. I hope you understand my point.
Yeah, understood. Understood.
Okay, fine. Uh, so we understand work packages are to be broken down into activities. Let us now understand what kind of dependencies or relationships could exist amongst various activities. Number one thing is there going to be any relationship or dependency amongst these activities? What do you say? Are they going to be all independent activities? They are not related to anything. Is it so? Mark? Is
Can you
there a
repeat?
need to have a relationship or dependency amongst the activities? Yes or no? Arman?
I mean, yes, because it has to complete that work package. There cannot be, for example, a
Definitely,
random
because
activity.
we have to
Yeah.
do things in some order, right?
Yes.
We have to do something first, then we have to do the next thing. There are dependencies, there are relationships. So we have to acknowledge that there can be dependencies in the project. But does that mean that every activity is kind of linked with every other activity? True or false?
No. No,
No,
because
that
yeah.
is not necessary. Some activities will depend on some activities. Rather, I would say the relationship is going to be between any two activities. If there is a dependency that would exist between two activities, and this dependency is a personal matter amongst those two activities. If the same activity is also depending on something else, that would be another relationship, that would be another dependency. So there could exist many dependencies in the whole project, but one dependency only relates to two activities, one on which it is depending upon and one which is dependent, right? We'll talk more about it, but what kind of dependencies could be there? There could be certain dependencies which we could call that they are mandatory, they are necessary, we can't avoid them. And there are certain dependencies which are discretionary in nature, meaning that, we have put them for better control, but if we don't need that kind of control, we can skip them. But mandatory dependencies are defined by the contract, by the by the customer, that that is their demand that this thing should be done in this order. So we can't skip that. That is like a law, like a rule. This is written in the contract. So those those conditions which have been made mandatorily imposable, they are called mandatory, and those who can be skipped or they are just for better control, they are discretionary. But there is another kind of classification also. Some activities, some dependencies are external and some dependencies are internal. Internal dependency is that it relates with the work of the project, meaning until this work is completed, we can't start the next work. This is the internal dependency. right? This is from the way of working. And external dependency is that this activity must be completed by 25th of December. You have been provided a fixed date, and now you have to complete that task by 25th of December by any means. This is a dependency which has been imposed on you from external resources. Or, for that matter, this could also be a dependency which has been dictated to you by outside resources, maybe through the contract. They say that you can't do this job until you have done this job. Well, that could be contractual, that could be a fixed date, that could be maybe a government obligation or government regulation that you can't do this until you have done this. For example, when before you complete the construction of a structure, you must make it earthquake proof, right? So earthquake proofing is a law. It must be done, otherwise your building will not be approved. So this is coming from external sources. It is not internal. I hope you understand all these four different, or rather I would say two combinations. One is mandatory versus discretionary, other is external versus internal. Comfortable with that?
Yes.
Okay. Now let me make it a combination of them. Actually, the dependencies would be of four types. Those which are external mandatory are those which are internal mandatory. And those which are external discretionary and those which are internal discretionary. So these are the four classifications you can actually create. Do you understand what I mean? So the four classifications would be external mandatory and internal mandatory, and external discretionary and internal discretionary. Just keep that in mind. Okay, here on this slide, I am showing you two activities. And they are like boxes. The blue box, the activity is confirm key stakeholder and customer attendance. And there is a starting point to that, and there is a finishing point to that activity. Similarly, we have another activity which says erect signage with customer branding. Again, there is a starting point to that, and there is a finishing point to that. These two activities are related. They have a precedence relationship. So we put an arrow between them to link them to show the relationship. What does this arrow mean? Yes, Arman? What does this arrow mean? How will you interpret it?
I mean, this has to go first, then that.
Say again?
This has to, so the beginning of the arrow has to go first before the other one. So
Right.
it will
The
initialize or
blue
first.
activity should have been completed as
Yes.
if the red activity can be started. Is it?
Yes.
Okay. Now you see that this you have actually mentioned the blue activity must have finished, right? That means the arrow is originating from the finish point of blue box, and it is terminating into the start point of the next activity. So this relationship is classically called as a finish to start relationship. The first finish represents the predecessor, the previous activity, and the second character start stands for the successor activity, the next activity. Now, between two activities, one has to depend upon other. You just can't say that they are interdependent activities. There is nothing like an interdependent activity in a project, because that will cause a total confusion. Either we do this first or we do that first. We must be very firm about it. What is to be done first? Right? Therefore, the activity which is causing the condition is called a predecessor activity. So we say the blue activity must have finished. So the condition has been imposed. The blue activity must have finished. That means the blue activity is a predecessor, or we can call it, it drives the relationship. So it is a driver. Once this condition is fulfilled, once the predecessor activity has finished, now the next activity is allowed. It is not mandatory. It is allowed to start any time. Now, you see, condition exists with the predecessor, and then the successor is allowed. It is not necessary that as soon as blue activity has finished, the red activity must start. I did not use the word must with it. So, condition is only on one side, must is only with the predecessor activity, and after this condition has been fulfilled, that the predecessor activity has finished, after that, the next activity, the successor activity, is allowed to start, I would say, anytime after that. It could start immediately, or it could start after an hour, after a day, after a year. We don't mind. It is not breaking any rules. The rule given to that activity was you can't start until the blue activity is finished. That is finished, condition is fulfilled. Now it is my will and my wish when I want to start, depending on the conditions in the project, right? If I have no problem, I can start many days later. If I have to be quick, I have to do something, I have to meet some other target, so maybe I do it immediately, I start it immediately after the blue activity has finished. So do you understand the concept of a finish to start relationship, which is the primary relationship in a precedence relationship?
Yeah, clear. My end.
Actually, what I would like is that whatever I have defined about this kind of relationship, I would like you to describe it in your own words, right? So, Mark, may I ask you?
So it's a prerequisite. So the predecessor, it's a prerequisite for you to start the successor.
Yes.
So
So,
meaning
predecessor is a prerequisite, right? Very good.
yeah. So I think that's the explanation.
Can you speak a little louder? I really can't hear much from your side.
I mean, that's the explanation that I have for this one.
Yeah, that is okay for the predecessor. But can you explain the whole statement once? The predecessor activity must have finished as if the successor activity can start.
First before you can start the next one. Yeah.
This is exactly what the finish to start relationship may look like. And that is the primary kind of a relationship which could be used in a precedence relationship. But that also indicates that this is not the only kind of relationship. There are other kinds of relationships also. But having said that, I agree that finish to start relationship is the most common relationship in a project. Sometimes 100% activities are related through finish to start, but in worst cases, it could be 80 to 90% activities would be related through this kind of relationship. Now, what are the other kinds of relationship? That is a big question. And we need to know that and understand that. And because This was straightforward. This was easy to understand. Be prepared to get into a little mind-bending exercise when I change the relationships to other types. If you have not heard those relationships before, you might have a little confusion. But I'll take you to that roller coaster journey. There are actually 4 types of relationships which could exist between any two activities. We have already talked about a finish to start relationship where the predecessor activity is the one from where the tail of the arrow is joined. And the head of the arrow gets into the successor activity. So A is predecessor, E is successor. This arrow is originating from the end point of activity A or the predecessor. So this is finish. First side of the relationship is finish. And it is entering into the starting point of activity E. So this S justifies that. So that makes it a finish to start relationship. That we have already talked about, right? Now, if you look at the start to start relationship, the arrow is not coming out of the end of C, ending point of C. Rather, it is originating from the starting point of C and entering into the starting point of F. I mean, it is the condition is that activity C, which is a predecessor in this case, should have started as if activity F, which is the successor, could be started. Please wrap your mind around this concept and try to understand it and explain to me how is that possible? Is it possible or not? Can you come up with some example where you see this happening?
I think it is. Maybe not a project, but a simple concept. For example, for start to start. So let's say I have a faucet, and the second activity is to flow the water. So I need to open it. That's the activity C for me to start flowing the water. So that activity F can start.
Okay. Marc, anything from your side?
Well, for me, I can hear you, Suhail.
Yes?
Yeah. So, should I give an example too, or would that
No,
be?
no,
Do you want
only
me to
this
give
one,
it?
start to start.
Start to start. Okay. So,
Yeah.
for example, so this has to start at the same time. So when you're writing something like a paper,
Right.
you cannot. Well, you can start editing or checking grammar only while you're writing. So both things start at the same time. Hopefully.
Okay.
So
I think I like this one. You should have started your writing
yeah.
as if you can start checking the grammar in it or
Yes.
syntax in it, right?
Yes.
Although one mechanism could be that first you write everything and then you check the grammar, but because you have started writing it, you can always go back and check the grammar and while the letter is incomplete. So in this case, I don't have to wait for the letter to be written first as if I can start checking the grammar. So start checking the grammar after you have started the letter. That is definitely a start to start relationship. Marc, please you think of something and give me a little break. I'll get back to you while you think about it. And when I get back, I want a similar example from you. I'm sorry. So I'm back. So we were to talk about the start-to-start relationship, and Mark, you had to give some example for that, just like Arman has given. Any example which comes to your mind from your real-time project or whatever from real life or what, I don't mind. But it should be a start-to-start relationship.
Start to start.
Yes.
So in order for me to attend this meeting, so
Mhm.
I need to open first my gadget. So I think in this case, I need to start working, which is to use my laptop for me to attend this class.
Okay. Can you repeat that? First, what is the first activity?
Oh, so opening my laptop
Opening your laptop. You must have opened your laptop as if you can.
so that I can call in
Right.
to
Very good.
this class.
Very good. The starting process should have started. The laptop should have been initiated as if you could do something on it. Right. Good.
Yes.
So this is natural. Although it is a little difficult, the most easiest relationship ever could be the finish to start relationship. We normally think in a sequence. So we say, okay, first I'll do this, and once I'm done with this, I'll do this, and then when I'm done with it, I'll do this. And we think in a sequence. But start to start is breaking a little law, but it is easy to understand. Both of you were able to create an example of that. Although the same example could have been a finish to start, but you converted it into the start to start relationship. That means any relationship can be converted from one relationship to another relationship, but there would be a little mind bending. Now, once you have fully understood the start to start relationship, let us think about a finish to finish relationship. And I must tell you, finish to finish relationship is even a little more difficult to perceive, right? So think of an example where the predecessor activity must have finished as if an other activity, the successor activity, can be finished. So, mind it, I am not talking about the start of a successor activity. That I don't mind when it started. It might have started many years ago or just now. But I am concerned about the finish points of those two activities. The predecessor must have finished as if the successor can finish. Can we think of a similar relationship?
So, uh, so for me, the example top of my mind would be system upgrade with downtime. So I cannot finish the downtime without finishing my system upgrade. So system upgrade should finish, and then downtime should finish.
Okay, let's rephrase it. Always give the predecessor activity first, which is
Okay.
posing the condition. So, what is
Okay.
posing the condition?
So the upgrade should finish, the system upgrade
A system
before
upgrade should have finished as if you could finish what?
the downtime, the overall application downtime.
Okay, fine. That works. So, Mark, anything from your side?
I couldn't think of anything about work,
I know it
but
is a little difficult to conceive, but if you put a little, um, you know, pressure on your mind, you probably can find something like that. They're not easy to think of. Actually, these other relations, other than finish to start, they are a little uh, difficult to conceive. But they do exist. They do exist. So if at all you can think of something, please let me know. Now, this start to start and finish to finish relationship, they are difficult, but they can be conceived somehow, and they can be used. What if we use these kind of relationships, the start to start and finish to finish? What is the advantage you will get? For example, the predecessor activity is 5 days long and successor activity is the 3 days long. In a finish to start relationship, it would happen one after the other. So the total time these two activities will take would be 5 plus 3, which is 8 days. But if you change the relationship from finish to start, it definitely is going to be less than 8 days. If predecessor activity, which is 5 days long, starts and immediately the successor activity, which is 3 days long, also starts, then within 5 days, both activities are done, isn't it? So miraculously, just by changing this relationship, I have reduced the time for these two activities from 8 days to 5 days. Saving of 3 days is a big deal. Similarly, finish to finish relationship will also save you time, but in different scenarios, it may save you more. But because the successor activity was just 3 days long, so it will just save you same time, 3 days. Because uh, D is finishing and E is finishing at the same time, then that means they will take 5 days, right? So 3 days is anyway saved. But what if D activity, the predecessor activity was 3 days and successor activity was 5 days? What do you say that? Both are to finish on 3rd of December, right? Scheduled date was, if it was scheduled for on finish to start, it would have it would have taken, say, 1st September, 1st December, 2nd December, 3rd December, 3 days for activity D, and then if it was finished to start, then another 5 days. But here what is happening is on 3rd of December, activity E will also finish, no matter if it was 5 days long. That means it might have started even before 1st of December. So looking at the actual calendar date, we are saving another additional 2 days.
Okay.
Do you see the benefit?
Yeah.
So although they are difficult to conceive, they are not very often used, but if you are compressed for time, maybe this could be a very good mechanism. But just by changing relationship, you could save a lot of time. Now coming over to the fourth relationship, which is called start to finish. Now this relationship is really tricky. This is really difficult to conceive because it bends your mind backwards. Predecessor activity is D and successor activity is F. It says the predecessor activity must have started as if the successor activity can finish. Now, no matter how you think about it, you definitely tend to reverse the relationship. I know the example you are going to give me is not of start to finish, but actually of finish to start. Try it out. What is your predecessor activity and what is your successor activity? Tell me. And let us see if you can make out a start to finish relationship.
So I think in Mark's example a while ago,
Yes?
so when bef- so the predecessor is for me to learn in this call or in this session, but the successor should be I should open my laptop,
Okay.
or is that a wrong? Because I'm trying to think. You mentioned I should just flip it, right?
No, don't flip it.
Okay.
Activity, the predecessor activity remain the same. right? Okay, tell me what is your predecessor activity? We'll talk about it. Let's take the same example you took for start to start. What was your predecessor activity?
Starting
You
starting to
must,
write.
okay, letter writing is first activity and checking grammar is second activity. Now let me
Yes.
convert it into start to finish. As soon as I have started writing the letter, the grammar check should finish. It is absurd, right?
Won't happen. Yeah.
As soon as I have started writing the letter, the grammar check should finish. How is it that possible? Right? So this looks like a very impossible kind of a thing. But actually, why I'm saying these relationships are mind bending because they look absurd, but if you think deeply, you think creatively, you think out of the box, you will find a way out. And if you find a way out, that is going to give you enormous benefit, right? I am not saying that this relationship may apply to every condition. Right now, like this example of letter and grammar, this start to finish thing doesn't fit in there, right? So we have to think more. We have to maybe go into more technology. We have to think into the future and something like that. We could come up with the justification for this relationship. But what I'm focusing here is that it is the same relationship between the predecessor and successor should remain the same, but the relationships may change,
How
right?
about predecessor eating? Then the the activity F is emptying my chocolate.
You can write it down in chat. The two activity one and activity two. Can you write it down in the chat window?
Mm, sorry, I need to ask Arman something. Arman, ano
Okay,
English ng bio?
let me give you an example. Say you
Yeah,
are
please. I'm
constructing
about to ask. Go ahead.
say you are constructing your house. So I am saying your predecessor is uh, laying of foundation and your successor is construction of wall, right?
Predecessor is laying of
Now,
foundation, construction of wall.
it is very easy to develop or finish to start relationship between these two activities, right?
Yeah.
Uh, think of it. How can they be done in right? Okay, I'll take your example. Act of eating, okay, and obtaining trash. Okay, fine. Mark has given a good activity. Act of eating, right? So, what do you want me to consider it in what kind of relationship? Start to finish?
Start to finish. As
Okay,
soon as you start
okay.
eating,
So let me write it down. Act of eating should have started as if the trash could be
Obtaining trash.
obtained. Is it right with you? So activity, the subsequent activity, the obtaining trash activity must complete as soon as your eating starts. No, sorry. Must, it is no, I'm wrong. Act of eating should have started as if I can complete the trash, complete obtaining the trash. Now, when I do complete obtaining the trash, it is not necessary that it is completed immediately as soon as I start eating, because that was the condition. This is an option. So I can keep obtaining trash subsequently over a longer period of time, but I cannot start obtaining the trash before I start eating.
Yeah.
I
So
think
you
this
need.
is quite understandable now. Now, this relationship, start to finish, is one of the most mind bending and difficult relationships. Usually, people can't come up with it, and especially using it in your project might be a very uphill task because you may have conceived it. How would you make your team understand what it really means? It is really difficult to explain to them because they all are thinking in a different frequency. So, start to finish relationship, even if you understand it, your team may not be able to understand. And therefore, precaution is that you should avoid this kind of relationship as much as possible. But start to start and finish to finish, these relationships are welcome. Why? Because they will save you time and they are not as difficult as start to finish. I can I can guarantee you the start to finish will save you a lot more time than start to start and finish to finish. But because it could be confusing, so we are avoiding it. Otherwise, start and finish relationship are little difficult to understand, but they are good and they are recommended in your project. I am not saying all of your relationships should be start to start or finish to finish, but if you have some of your activities with this relationship, then it is highly encouraged. That remains a rule that most of the activities in a project are linked through finish to start relationship by default. By default, right? If you design a project in which there is no finish to start relationship, then I would say it is not planned well at all. There cannot be a project in which there is no finish to start relationship. So, finish to start relationship is mandatory. It should be there, and it is kind of it is good to have some start to start and some finish to finish relationships in your project, but it is all right to avoid start to finish relationships. So I would say 80 to 90% of the relationships in your project would be finish to start. Remaining should be start to start and finish to finish, and we will try our level best not to use start to finish. But if you are sure that you understand it well, your team understands it well, and they can apply it without any confusion, then you can use one odd case of start to finish as well. An unrelated example of start to finish could be that there is a guard working on night duty, which you call graveyard shift. His duty started at 6 p.m. the previous day and it will finish on 6 a.m. the next morning. There is another guard who is going to take over the position from him, the guard position from him, at 6 a.m. the morning and will serve until the 6 p.m. that evening. Right?
Okay.
But we have put a condition that the night guard is not allowed to leave his position until the the day guard has arrived and taken over the post, right? So who is depending on whom? Night guard or day guard? Who is depending on whom?
I mean, yeah,
So the day guard is dependent to the night guard.
Day guard is dependent on night guard. Night guard, I'm sure about it. I'm saying
Because
condition
like
is the night guard cannot leave the position
it's the other way around
until
then.
the day guard has come. So
Yes.
the night guard leaving the position is dependent on the
the
day guard
arrival.
arriving.
Yes.
So the person who is coming later, the day guard, is the predecessor, and the person who was working already is the successor. And they do have a start to finish relationship, meaning the predecessor should come and take on this position. He should start his work as if the previous guard can be relieved of his duties and can go home. This is a book example given in PMBOK about the start to finish relationship. Are you absolutely clear about all these four kinds of relationships?
Yes.
Very
Well,
nice.
start to finish,
Yeah.
still a bit difficult, but
Now, while we are on it, let us learn one more thing about the relationships, and that is whatever kind of relationship you are having, you could have overlaps or gaps between them. They are called leads and lags. Let's talk about the lag first. Lag is that I do have a relationship of finish to start between A and E activities, but I am putting an extra condition that after the culmination of A activity, you have to wait for 2 days before you can start activity E. So I am giving a lag time to the finish to start as if E activity can start. So in a way, I am saying E activity is not allowed to start until 2 days have passed after activity A has finished. Do you understand this? This is an example of a lag, lag of 2 days. And how do we show it? We'll show it like we say finish to start plus 2. Lag is a plus.
Okay.
It is a gap. It is more time. And what if I'm trying to create an overlap between A and E? I can say activity E can start a day earlier than activity A has finished. That means what is the scheduled date of ending activity A, finishing activity A? Say that was 2nd of December. So activity E is allowed to start one day before the 2nd of December, meaning activity E can start one day earlier. And that relationship would be like finish to start
It's
minus
-1.
1.
-1. Okay.
This is an example of a lead. Lead is negative, lag is positive, and we can use these leads and lags in our network diagram.
So question. So meaning the moment you put a lead time for finish to start, it becomes start to start
No, no, no,
with a
no.
lag.
No, no, no. Finish to start doesn't become start to start. Start to start is a different relationship.
But
Say again.
but so for example, so finish to start, let's say the entire duration,
Ah, mhm.
5 days and 3 days. To your point, right? So five
You are
plus eight.
talking about the guard example?
No, just a typical number
Okay.
regardless of the example.
A is 5 days and E is 3 days,
Days, yeah.
right?
If you have a lead time of 1, then it becomes 5 plus 3 minus 1. So it means, if we try to explain it, activity E can be started even if you haven't completed yet activity A.
Yeah,
Or
that doesn't matter. That doesn't matter.
and
If I'm saying
explained
I need that
differently.
time, so maybe A is yet not finished, but because the scheduled date to complete was 2nd of December, so I am allowed to start on 1st of December. I can start E activity one day earlier than that. Now,
Yeah.
as far as the matter of activity A getting delayed, that is another subject. That is not of my concern. According to the schedule, it says that when A is scheduled to finish, from that day, one day earlier from that, you can start your activity E. That would be finish to start minus 1.
Yeah, but I'm just saying, what if I stated it differently? I stated differently, like you can start activity E 4 days after you start activity
No,
A.
no, no. See, activity getting delayed is another subject, and we deal with it. We have mechanism, right? We will report this matter. There will be a change request. So there will be a change maybe in the network diagram or in the schedule. But don't try to mix that delay of an activity with the relationship of an activity. Relationship is established much before the activities have ever started. This is planning. Now you are talking about execution. What if the activity A gets delayed? So let it get delayed. Activity A, we in our schedule, we have a start date written for activity A and a finish date written for activity A, isn't it? If you know the finish date as per the schedule, you can start E activity one day earlier from that. It doesn't matter when the activity A will actually finish on ground. That is a matter for project manager to resolve. But the activity E person will start on the scheduled finish date of activity A. That is when we are talking about finish to start minus 1. Activity A is say 1 to 8, and activity E would be, say, from 10 to 12. Sorry, not 10 to 12.
Okay.
It would be 7 to 10,
So 12 until
right?
10. Okay.
So it finishes at
Okay.
8. I start at 7. So I start right like this, a day earlier. Got it? So I
Yeah.
start from 7. So I finished on 10. So otherwise, this 5 plus this 8 plus 3, 8 plus 3, normally finish to start, 8 plus 3 could have taken 11 days. Now, Fs minus 1 is taking 10 days, right? And if it is Fs plus 2, it would be taking 13 days. Got it?
Yes.
So you don't have to confuse it with actual date of completion. That is not the matter to be considered at this stage. We are scheduling things, we are planning things. So in the plan, we can calculate things from the scheduled dates, start and end date of an activity. We are not concerned about the actual date of completion. That is a subject of monitoring and control. So far, so good.
Mhm. Yeah.
Yeah.
Okay. These are some terminologies, as you were saying. Activity duration estimate is an estimate. Again, I would say this is something we do in planning, right? Estimate is estimated in planning. Elapsed time is something which has to deal with the actual calendar time required for an activity from start to finish, right? I mean, when we are in execution, how much time an activity will take on ground. That is the actual calendar time. And effort is the number of labor units required to complete a scheduled activity. Now, this is interesting because now we are talking about effort. How many people are required to do this job? What if that many people are not available? Naturally, the activity will take more time. So, effort is also a concern for us, which we are going to talk about later. But effort is mentioned, average number of people required to do this job, that is the basis for calculation. But once the actual available resources are available on ground, then we would find that, okay, we have to reschedule it, we have to adjust the plan according to the new numbers available. But anyways, we must understand that effort should be counted in uh, in the units of time. But whatever unit you select, it should be the unit used in the whole schedule. If you are calculating time in hours, then your progress will be measured in hours. It is not possible that one activity is being calculated on the basis of hours, another activity is in days, another activity is in weeks. In weeks, we have to convert it all into one single unified unit. Okay, I think we can take a break and then we'll talk about the estimation techniques. Will it be all right if we take a 10-minute break?
Yes.
Okay, then we have a 10-minute break. Here you go. See you after 10 minutes. Okay.
Suhail, I'm back, but
Yeah,
I
I can
cannot
see
turn
you.
on my camera for now.
Yeah. Mark is not here.
No, this is Mark talking.
Okay. So that means, should I start?
Yes.
Okay. Okay. Right. So let us talk about the estimation techniques. And I must tell you that these estimation techniques are common for all kinds of estimates. Like we are doing the duration estimate. They are the same rules apply to the cost estimate, to the resource estimate. Actually, in project management, we have got three different types of estimates: schedule, cost, and resource. And these are the standard methods which could be used anywhere in all three types. So these methods are analogous, parametric, 3-point, and bottom up. In the order they appear, the lowest one, the bottom up, is the most accurate method, and analogous is the most arbitrary method. This is not very accurate, but still they are doable. They are for the purposes of project management, and they are not completely you know ballpark figures. It is not a ballpark estimate or a lump sum estimate, but these are quite sensible estimates. What is a analogous estimate? That is when you are trying to compare an existing project activity with your experience in the past. You say, I have done this kind of job earlier, and when I did then, it costed me this much money, or it took this much time. So, taking an analogy from your past experience, you fix, you put a time or cost, whatever estimate you want to put. You say, okay, because it took around 5 days in the earlier experience, so maybe it will take 5 days now as well. That is a one-to-one analogy. But analogy cannot only be one to one, it could be one to n or n to one. That means this activity took 5 days earlier when I was not very experienced. Now I'm quite experienced. So I suppose I can do it now in 3 days. Or maybe there could be another analogy that previously this took 5 days, but that was a much simpler task than this. This task is doubly difficult. So let me put 10 days to this activity. So you are always making a reference to your previous experience and developing an analogy from it, which could be one-to-one analogy, which could be one-to-n analogy, which could be n-to-one analogy. But this type of estimate is called analogous estimating. And this estimate, as I said, could be applied to time, cost, or resources. All three types of estimates could be analogous. Well, as you understand, this is not a precise way of estimating, but it is doable. We can work with it. Then we have got the parametric estimating. Parametric estimating is a bit better than analogous estimating. And what we do in parametric estimating is that uh, all our past experiences, we summarize them, and we uh, kind of take a statistical average of that. And we say, okay, if usually we do this kind of thing in this much time, then uh, what is the unit time required to do that? For example, I say usually it takes, some people say it takes 10 days, some people days it takes 8 days, some people days say it takes 4 days, but on average, we say that this much job can be done in 1 hour. So whatever is the amount of work I have, say I think that one 10 units of work can be done in 1 hour, and I now have 20 units of work, then I will be able to complete this work in 2 hours. You see, this is a little better calculation than the analogous estimating. We are establishing a parameter, and using that parameter, we can make our calculation. Do you get that?
Yes.
Have you ever used the parameter estimating?
I think we often use the
Yeah.
parametric.
Yes, very good.
Mhm.
Okay, so parametering is having a calculation for a unit, and then you can multiply that unit with your total work. Then we come to the 3-point estimate, which is even better. In 3-point estimate, we don't take just one value for the estimate. We talk to many people. Again, it is a statistical method. We talk to many people, and some people just remember the rule for that. If you take opinion from many people, most of the people will have the common opinion. Have you ever experienced that? If you talk to 100 people, you ask a question to 100 people, most of the people will almost have the similar opinion. Majority holds the similar opinion. For example, you ask them, how much time will it take to do this job? So maybe 60 to 70% people would say, well, it could take about 3 days, right? But there would be some people who are called outliers, like they are either too optimistic or too pessimistic. So you have to consider their opinion as well. Why? Why do we need to accommodate the pessimist and optimist in our calculation? What does a pessimist represent?
A risk.
For example, a pessimist thinks that this job cannot be done in less than 10 days, which is a very different opinion from the majority. Why should I even consider this?
So I think because it happens, even though it's rare, and there are some risks behind it. That's why it will take more time. I think that's the pessimist.
Yes, of course,
So
very right. You have said this is because that person had a bad experience earlier, and he unfortunately faced such circumstances which actually he could not do that job in less than 10 days. So naturally, he is adamant that it can only be done in 10 days, right? This is because that person has seen negative risk, and his experience is based on that. So I do not want to discourage this person. I want to take his opinion into account, because I also can be so unlucky to face a similar kind of risk. I must make space for that. Similarly, I have to consider the optimist, the person who says this job can be done in 1 day because I have experience, I have done it. That is again the risk, but it is the positive risk. This person was lucky enough that everything turned in his or her favor when he was trying to do that job. And he is now adamant that this job is so easy, it can be done in 1 day. Whereas the majority of the people are of the opinion it must take around 3 days. So I cannot ignore the optimist or the pessimist. So what we do is take a 3-point estimate. We consider all three opinions, but it is not matter of a simple taking a simple average, because all the three opinions are not equal. So to the majority opinion, which is the most likely opinion, I give 4 times more weightage. I give 1 time weightage to the pessimist, 1 time weightage to the optimist, and take a weighted average, and that would be pessimistic view plus 4 times the most likely view plus optimistic view, all divided by 6, will give me a 3-point estimate. It is a weighted average, and that is a pretty good estimate. Statistically speaking, this is a pretty good estimate. But again, I would say this is not the most accurate one. So out of the previous 2 examples, like analogous and parametric, 3-point estimate is much more accurate than analogous and parametric. But we are still to discuss the very last option, which is called a bottom-up estimate. You see, in analogous parametric at 3-point, we did not bother to calculate each nuts and bolts of the activity. We did not actually calculate anything at all. We were just making guesstimates from the previous experiences. Bottom-up estimate is when you physically put 2 and 2 together. You say, okay, this is the job we have to do. This much money I have to pay to this person. He will take this much time, and that kind of thing. Put it all together. I calculate physically for each and every activity how much time this activity will be taking. This is called a bottom-up estimate. This is done for every activity. Then all the durations are somehow added up, and then we find the total duration of the project. So bottom-up estimation is cumulated upwards. But unlike the cost estimate, as I gave you the example earlier, it is not simple addition of all the costs, which can give you the total cost. As you answered me earlier, in time, we do need to see which activities are happening in parallel, and then we will use the critical path method to determine how much time will it take in total. It is not simple addition of bottom-up calculation, but for resources, for cost, especially for cost, we can add all the costed, which could cost to get the total cost of the project. But anyways, that is beside the question. So bottom-up, by and far, is the best approach and the most detailed approach, and it works from bottom up. Then we have other approaches which work from top down. Top down approaches are, I don't really need to discuss it here, but that is when the business case is being developed. They imagine a budget for the project and then break it downwards to the activity level, which is not a very good way, but naturally at the level of developing a business case or developing an outline plan, probably we would be using those top-down approaches. But for the estimation of activities, these are only the four techniques. Okay, here you find the formula for 3-point estimate. One thing I must mention, actually I gave you the one on the right-hand side. This is called beta distribution when I am collecting the opinion from a large audience. Generally, I would say for more than 100 people, maybe, or maybe if you are not having 100 people, for maybe more than 50 people. When the people are many, the estimation could be varied, and therefore beta distribution can apply, and I can use a weighted average formula here to calculate my time. But if I am taking opinions, say, from only 3 people or 4 people, if the audience are not many, this is called a triangular distribution, in which we take a simple average of 3 values. Simple average. That is the only difference between these. Both are called 3-point estimate. But if the opinion is coming from very few people, apply triangular distribution and a simple average formula. If there are many people, 50 or 100 people, from which the opinion has gathered, so that would become a beta distribution, and you have to take a weighted average like this.
Question.
You will see this calculation. If the optimistic is 3 weeks, most likely is 5 weeks, and pessimistic is 10 weeks. By the calculation of triangular distribution, it comes out to be 6 weeks. By the calculation of beta distribution, it comes out to be exactly 5.5 weeks. Although I do understand that difference is not very much, but still the beta distribution is considered more accurate. Are you fine with the idea?
Yeah, but maybe a random question. Why is it 4?
Say again.
I mean, in the formula, why is it 4?
Okay, very good question. Let me draw it for you to give you an idea. I may not be really accurate, but this actually is based on statistical distribution, which we call a bell curve. You might have been aware about a bell curve. Bell curve looks something like a bell with a center line, and the positive side and the negative side. Most of people, the height of this point is the number of people who have opined on that. So opinion of most of the people is, most of the people, say X people, these people are saying that this job can be done in 3 days. But one odd person, a pessimist, is saying this can be done in 10 days. And one odd person who is the optimist, he's saying this job can be done in 1 day. But these are very few people. Their opinion does not match with the opinion of the majority. So let us divide the whole bell curve in 6 parts, 3 parts on the left hand side, on the negative side, and 3 parts on the positive side, which gives us 6 divisions. These divisions are called deviations. So from the center, the 3 deviations are on the positive side and 3 deviations are on the negative side. So if I consider the pessimist to be a minority that is covering this portion, and optimist is to be the majority, a minority again, which is covering this portion, then this area, whole of this area, 4 deviations, is populated by the majority. So I give them 4 time weightage, and I give this guy 1 time weightage, and I give this guy 1 time weightage, which means 1 plus 4 plus 1, 6 weightages. So if I take a statistical average of a triangular distribution, the formula would be this one. And in this, we can also have our the one deviation size can also be approximately calculated by this formula. Pessimistic view was 10, optimistic view was 1, right? So 10 minus 1 is 9, divided by 6. So my one deviation size is 1.5 days approximately. But anyways, right now, you are not concerned about the size of the deviation. We are only concerned about the estimate of duration estimate. So duration estimate in beta distribution is like this, right? But in triangular distribution, because the people with whom I am conversing or collecting data, they are quite a few as compared to the beta distribution. Therefore, the fineness of the curve, these curves are not going to be so curvy. Actually, the shape of a triangular distribution is like a straight line joining from here to here and a straight line joining from here to here. This is called a triangular distribution. And in this case, say we have only 3 opinions and they are of equal weightage. So I take a simple average like this. If in the exam you are asked a question about this 3-point estimate or standard deviation, and they have mentioned that this is the optimist value, this is the pessimist value, this is the most likely value, and you have to use the triangular distribution, then you will use this formula. If they have specifically mentioned it is a beta distribution, you will use this formula. If they did not mention anything, then you must always use beta distribution by default. I hope I clarified that thing.
Yeah, I mean,
Mark, are you fine with it?
I understand the concept of weighted average. I'm just curious, why does it have to be 4 and not 6, then over 8 or something?
So yeah, so for the weighted part, I mean, I do agree with Mark. I still don't get why did we use four M?
Actually, I can go into the detail, but you see, what I have explained on this sketch is probably what is required to understand it. Approximately four deviations represent the most likely opinion.
Mhm.
So it gets
Okay.
4 times more weightage, right? And approximately, one weightage is given to a pessimist and one to the optimist. But if you want really to understand it in more detail, I would recommend that you should consult some book on statistics and try to understand the bell curve. That will clarify you. Because there you will find more reasoning and more scenarios to play around with. I am talking to you in a very layman language. I'm not using the technical jargon about statistics here. So that's why I'm just trying to make you understand the concept in a basic layman language.
Okay.
If you have a specific question, probably I can try to answer that, but I am not really understanding what is the confusion here. Yes, please. And because I'm also having problem hearing you, so it is fine if you can write your question down here as if I can grasp it completely and give you a specific answer on that.
No, I think we're good for
Yep.
now.
I'm good. Yeah.
Okay, if you are okay with it, then should I move ahead?
Yes.
Yes.
Okay. Right. So we are done with this. Moving on. This is the interesting part. This is called your critical path. A very basic concept on that is that all the activities on your project, right from the start of the project till the end, they are not going to happen in a sequence. There may be certain paths which are in parallel to each other, and those paths might be taking different time frame. Therefore, if you travel on one path, it might be taking, say, 14 weeks to end the finish point, whereas the other path might be taking 16 weeks to reach the end point. So you have a conflict here. How much time is this project is really going to take? Is it going to be 14 weeks or 16 weeks? And this is just an example. Here we have only two paths. In a complicated project, there could be many paths, many entanglements, but one thing is sure that everything starts from a start point in a predictive project and everything finishes on a finish point. You can see that in this simple diagram, there are no loose ends, right? The arrow starts from start and gets into this activity. You see, we don't have a missing arrow, right? If this arrow was not there, then this diagram was incomplete. It should have been well connected diagram, no loose ends, starting from the start, ending in the finish, and it may have several paths to get to the finish point. Now, every path may have different duration on that path, but one path is going to be the largest of them all. So which path, the shortest path or the longest path, should I consider as my critical path?
The longest.
The longest path. And what is the reason for that? You see,
It's
we have identified that these are all the activities which are to be completed as if the project can be declared complete. If I take the shortest path, there are only 4 activities which are ending at that point in time. These 2 activities now are not included. Although this time is overlapping with this time, but this time is more than this time. Therefore, uh, the shorter path is taking 14 weeks, but the longer path is taking 16 weeks. That means if I consider the longer one, then by the time I am done with 16 weeks, 14 weeks of the upper path would anyways have been completed. And I can assure that all the activities in this project have been completed. That is why I go for the longer path. And the longer path, rather, I would say the longest path, because there might be more than 2 paths, is called the critical path. This is the minimum time required to complete the project. Project cannot be completed before 16 weeks. But this is what I'm saying from the point of view of the whole project. 16 weeks is the minimum period of time which is required to complete this project. Why I'm saying minimum? Because I am talking about the total duration of the project. But if you are comparing the paths within that project, this is the longest path, which represents 16 weeks. All other paths are shorter than that. So that means we have 16 weeks to complete this project. And if a path gets completed in 14 weeks, they will have some float time to enjoy. They will have no work to do, but they can relax and enjoy for 2 weeks. But while we are working on the remaining work of the project, so that means there is no float on critical path. Activity 1, 3, 5, and 6. These are the 4 activities which cannot be delayed. If any one of these activities are delayed even by a day or a week, the whole project will be delayed by that much time. But if activity 2 and 4, they are delayed even by 2 weeks, project will still complete in 16 weeks. I hope you understand my point.
yes.
So there are 2 ways I can express a critical path. Critical path is the longest path amongst the various paths available to reach from start to finish. And the duration of the critical path is the shortest possible time the project can be finished. Do you agree with my both statements?
Yes.
Very nice. I suppose you are already aware about the concept of critical path. That is why you are understanding this. Okay, this is an example uh, of a critical path, but I personally do not agree with the calculations used here because we usually should start at point 0. He has started on point 1 and manipulated the calculations a little bit, whereas the correct calculations would be like starting from 0, and my answer would be the same. I would also get to the 11 days, but we should start with a 0 point. I'll show you how it works. I'm just going to amend some of the calculations here. Like I will replace this 1 with a 0. And if I start A and B activity, actually, let me describe this thing first. This is the earliest start date. The project, when can an activity be started the earliest? If I talk about A, the earliest start date is equal to the start point. Whatever is the date on start time, that is the date I put here. If it is 0, it is 0. So same is true for B. So earliest finish is, if I add duration to earliest start, I get earliest finish. So 0 plus 3 is, this is correct, 3. 0 plus 4 is 4. This is correct. Okay. Similarly, I keep moving forward with earliest start and earliest finish dates. So I will be calculating all the earliest boxes. So let's move to activity C. This figure 3 should come here. 3 plus 2 is 5. 5 is correct. This figure 3 should come here. 3 plus 4 is 7. That is correct. Now, for activity E, we have two things coming here. One is 4 and one is 7. So we have to pick a choice. What should we take? That means the relationship of E is a finish to start with D and finish to start with B. That means D should have finished as well as B should have finished, right? B gets finished on 4 and D gets finished on 7. So when can E start? E can only start when both have finished. So what value should I take? When can E start?
7.
7.
D7. 7 plus 4, yeah, because
7 is the correct answer.
yes.
So 7 plus 4 is 11, which is correct. Okay, let's talk about F activity. There are two arrows coming here. One is 7 and one is 5. What should I write here as a start date?
7.
Very good. So if I write 7 here, 7 plus 3 is 10, which is correct. You see, just because of the different method they have used for calculation, they started with 1, but only affected was their earliest start dates. They all went wrong. But other calculations are all right. Right? Okay. Now that I know this project can be done in how much time?
11.
11 days. So now let us calculate, what if I complete everything at the very last possible moment? That is, project is to finish on the 11th week. What if the last activities do finish on the 11th day? I bring this 11 here and here, right? So now let us subtract the duration from 11. So it comes out to be 11 minus 3. What? What is 11 minus 3?
8.
8.
So it should be 8. Okay. What is 11 minus 4?
7.
7. Good. Now let us travel backwards. This 8 will move here because there is only one arrow. So this is correct. And this 7 will travel here. But there is a conflict. 8 is coming from here and 7 is coming from here. What value should I take? It is a backward path. There are two reverse arrows. 7 is coming from here. 8 is coming from here. What should I choose? 7 or 8?
Is it 8?
Okay, to make your life easier, I would say, because it is a backward path, the rule is reversed. When it was forward path, I was taking the higher value. Now I am traveling backwards in time. So I will take the smaller value. So out of 8 and 7, the smaller value is 7. 7 minus 4 is 3. Now, what do I have here? Do I have here? Okay, I did not calculate this one. 8 minus 2 is 6. So I have got two options for this point. 6 or 3?
3.
3.
3 is okay. And what about this one? Here, the 7 is coming here. So 7 minus 4 is
3.
3. Now, these are the correct calculations. Do you agree with me?
Yes.
I would like you to calculate it that way. So
Okay.
we have done earliest start, earliest finish, latest start, and latest finish. They all have been calculated. The only thing left out is float. What is the formula for float? For float, I can use either latest finish minus earliest finish, or I can use latest start minus earliest start. They are both equal. You can check it. What is 7 point minus 4?
3.
And what is 3 minus 0?
3.
You just cross check. So my float for this point, let me use a different ink for that. Okay. So my float is 3 days. What is the float here? Just tell me, what is the float here? A.
0.
What?
0.
0.
Good.
0.
And what is the float here?
3.
3.
Very good. And what is the float here?
0.
0.
And what is the
0.
float here?
1.
1.
And what is the float here?
0.
0.
0. Now, let me highlight the path which is having 0 float. You see, this is the path. This is the activity, which is critical activity. Any activity which is having a 0 float is a critical activity. The path goes here. Again, I have a 0 float.
Okay.
Then the path goes here. Again, I have a 0 float. And then path reaches the end point. So it starts from start and ends, and there is one path which is going to have 0 float throughout. And that path is called a critical path.
Critical path.
So let me use a different ink and let me make this path more prominent. This is 0, this is 0, this is 0, and this path is like this, and this is my critical path. All the activities on critical path will have 0 duration, sorry, 0 float, right? Therefore, all the activities on critical path are called critical activities. All other activities which are not critical, which have got a float of some kind, some have got a float of 3 weeks or 1 week or whatever, they are called non-critical activities, and they have got a kind of allowance that this activity, you see, the B activity, it can be done in 4 days, but it can be delayed as late as seventh week. So this has got a float of 3 weeks, right? And meaning it has a wait time, it has a rest time, it has a float time. So that way we can calculate this. And if I see any of my critical activities A, D, or E are getting delayed, I must be alarmed because my project then would not be able to complete in 14 weeks, 11 weeks. It is going to take more than that. That means my critical path is impacted, my project is going to be delayed. But if C activity gets delayed by 1 week, or F activity, or B activity, that does not matter to the end date. The project can still be completed in 11. I hope you understand all this thing.
Yep.
Have you ever created this kind of a diagram in your practical life, in your projects?
No.
No. Yeah. I use MS projects.
MS Project. Okay, well, MS Project is a fantastic tool, but for computers, they say garbage in, garbage out. If you don't know how to do it, then the computer is a useless machine. It doesn't know what is the sequence, how things should be done.
Yeah.
Trust me, If you have not created a critical path, you cannot assign time to activities. You cannot develop a Gantt chart. But unfortunately, the people who are using some kind of computer software for project management, the first thing they develop is a Gantt chart. That means they miss out on all other work. They have not done correct estimations. They have not established the correct relationships. They have not drawn the network diagram. They did not establish the critical path, but they just created a Gantt chart and then they start relying on it. Gantt chart can be created with a fake data, with the wrong data. And it can show you a critical path, but if the Gantt chart is wrong, your critical path will also be wrong. Your calculations will also be wrong. So don't rely on computer to make a critical path for you. You have to create a critical path intelligently and then cross-check with computer if it responds with the same answer. Anyways, now let me highlight to you what is the benefit of creating this critical path and this diagram. So I will just make a little space here as if I can create a Gantt chart, because you see, actually I can create a complete Gantt chart just based on this data. This is the data I require for creating a Gantt chart. I don't require anything else. Right. So what do I know? I know I need 11, let's call it days. We need 11 days to complete this project. So I will draw a straight line from this point. Let me take a better color and yeah. Let me, from the start point till the end point, I make a straight line which should represent how many? 11 days. And this is my 0 point. So let us make a, marking here. Okay, say this much is 10 days and this much is 5 days. Then this would be 4, 3, 2, 1, 6, 7, 8, 9. Can you clearly see all the 10 days now? 11 days, right? Then I draw a straight line upwards to represent my activities. So I will have the last activity is, say, F, E, D, C, E, and A. Okay, tell me the earliest start and earliest finish date of activity A. Let me just draw straight parallels as if you don't have difficulty. So this line is the line for 5. This is the line for 10, and this is line for 11. Right. So if I start A on date 0, it will go up till here, right? So the bar of A activity would be like that. It starts from a 0, ends with a 3, and this is A. What about B? B is from 0
1
to 4.
or
It would be something like this. So it starts with 0, ends with 4, and this is B. What about C? It is 3 to 5. So it starts from here and it goes till here. So 3 to 5, this is C. Then let us talk about D, is 3 to 7. It again starts from here. It goes until here.
7.
So this is a bar for D, 3 to 7. What about E is 7 to 11.
11.
This is E 7 to 11, and F is 7 to 10. So it goes something like this. It is 7 to 10 F. So I simply drawn the dates which I have calculated on the network diagram, I mean the critical path, and I have plotted them, and I got my Gantt chart. This is how Gantt chart is created, not the other way around. You don't create a Gantt chart and then ask computer to tell me what is the critical path. It has to come out of the critical path. It should be based on the critical path. Then it will be a correct chart. But the story doesn't end here. The story gets more interesting because we have another set of dates. Let me change the color for that, and let us draw another Gantt chart on top of that. And let us say I have blue color with me. So now you will tell me the the latest date, latest start and latest finish date, right? Anyway, this was 0. This was 0, right? Okay, so my color here is now blue. And tell me what is the earliest start and latest start and latest finish for A?
0 to 3.
Latest. This is the latest start and this is the latest finish. 0 to 3.
Yeah.
So it is the
3.
same as the earliest date. So I will plot that on top of the already placed dates. For B, the earliest was 0 to 4, but the latest is 3 to 7. So I have to start from the 3 point and go until 7. And this is my bar for doing this job latest. So this is 3, this is 7. What is for the C is 6 to 8. So it starts from here and goes until here. 6 to 3, 6 to 8. This is my C. What about D? D, we have got this, that it is critical activity, so it remains where it is. And what about E? Again, a critical activity, it remains where it is. And F activity is 8 to 11. So it starts now, latest it can start here and it can end here. So it is 8 to 11. Now you see, all the critical activities are actually being done in a manner this is a critical activity. So you see, earliest and late dates are same. Then this is the critical activity. So I can join it like this. And then this is the critical activity. I can join it like this. So my critical path would be
8.
Like this. It moves here, moves here, moves there. This is my critical path. This is my critical path. So anything which could be represented on the network diagram, critical path, it can be represented in the Gantt chart. Now, one thing, where is float? Let me show you the float. Let me show you the float, and for that I may have to change the color. Okay, in A there is no float, in D there is no float, E there is no float because they are critical. What is the float in B activity? You see, let us look at the finish point, the earliest finish point. This is the earliest finish point, and this is the latest finish point.
7.
And the gap between these two is my float. The float is 3 days. Is it true? Is the float
Yes.
3 days?
Yes.
Okay, let's talk about C. This is the finish point and this is the finish point. What is the distance between these two? It is 4 days. Is the float for C, which activity is this?
It's 3.
Three. It's only three. So
What did I do wrong? B was float was 3. Okay, 5, 6,
I
7.
think it's
Oh,
5
yes,
days.
it is 3 days. It is 3 days. So this is again correct. And what about the F activity? The finish point is here and the second finish point it is here.
one.
This is my float 1 day. So this is also true. Got it? Are you
Uh,
convinced that all the data which was represented in the network diagram or the critical path, it can be represented on a Gantt chart? That means once we have completed the critical path, that data can directly be translated into the Gantt chart. So develop a critical path on your Microsoft project. Don't look at the Gantt chart at all. There is an option you can change the view.
Yeah.
So change the view to network diagram, do all these things, and once you are okay with it, then you can get back to your Gantt chart view. Automatically, your Gantt chart is ready. I hope you understand my point.
Mhm.
Yeah.
Okay, good enough. So while you absorb this, we can have a little break. Let us have a break about 15 minutes, and then we'll get back to it, and then we'll talk about another half an hour, right? So let
Okay.
Yep.
us have a break. Are you comfortable with it? Do you want this break?
Yes.
Yes. Yes.
Okay, then. I am setting that time to, let us say, 16 minutes. And at exactly half past, we will start. So thank you very much and take care. Welcome back.
Yep. Hello.
Hello.
Mark, are you there?
Yes.
Okay, good. So let us move on. For the rest, half an hour, we'll try to study as much as schedule we can cover. So once we have done all that, we have created the Gantt chart. Now, this is the first time the things have emerged in the shape of a Gantt chart, and we can visually see how the things will occur. Now we have to see to make certain adjustments. Maybe, as I mentioned earlier, maybe the adjustment is due to the change in resources, or maybe there are requirements for compressing the schedule. We will have to do that before we can get this schedule baseline. That means before getting this project baseline, we have to make certain little bit of adjustments, and this schedule is going to change. The dates are going to change, and when we think that is has been stabilized and there are no more immediate changes required to be made to the plan, this schedule is presented to the higher authorities as if they can approve it and baseline it. Because once they baseline it, then they have the authority to change it. We cannot change anything without their permission. So we have to move a change request if there is anything to be changed after the baseline has been done. Just uh, keep that at the back of your mind that before creating the milestone, before creating the baseline, we must make all adjustments and corrections. Be very careful about it. And after that, then once the baseline has been created, it cannot be changed by the team. We have to seek permission from higher authority. Now, once we have the final schedule, it could be, portrayed or communicated in various different formats, because this is the ultimate shape how the things will occur. But maybe some stakeholders do not require to see the whole chart. They just need to see milestones. We will show them just the milestones. That is the beauty of the software. If you are using the Microsoft project, you can allow a specific view of the screen to specific stakeholders. That means if that stakeholder will like to watch the schedule, they will only see, for example, the milestones. If there is a team which is working on phase one, they will only see the schedule for phase one. They will not be shown other schedule, the complete schedule. That way, anyone who is more interested in network diagram can see the network diagram. Anyone who's interested in the roadmap can see the roadmap. All this information is actually stored in the schedule in Microsoft Project or Primavera, whatever software you are using. Now, these are some of the views how a Gantt chart in various different softwares may look like. I know this is not the view of MS Project. This is some other software, but it is also a great software because I suppose it has more clarity in it. But naturally, may not agree with everything given here. So normally this is the format. In the first column is usually the activities written. You could show the activity number on the left-hand side. You can make it visible. The duration of each activity, there is a column for that. Then there are optional columns. You can add several other optional columns. You could even show here a column which shows the predecessor or successor relationship. Dependency. Who is responsible for that specific activity? How much progress has been made on that activity? So it is not only for creating the Gantt chart, but it is also for monitoring and controlling and adding progress to it. And your bars will appear against each activity like this. And when you are trying to put a progress in it, your activity may be represented in that specific activity. Say, this is your progress. So progress could be marked right in the middle of the marker. Okay. For example, today is 20th of June. So on 20th of June, let me draw a straight line on 20th of June, like here. This is today. And today I am taking the progress. And this job was completed in this much time. And this activity has started late. Sorry. This activity has started late and it is yet not complete. Sorry. Oh. Okay, say it started from here, it started late, it just got to this point and it is incomplete. This activity was held back at this point. This activity was started maybe earlier and it finished at this point, right? Somehow we could represent the progress going on. Moreover, we can also represent the usage of each one of the resources. So these are the people who were assigned different activities. So here this is Karina Young. Here, this is the commitment of Karina Young on these activities. So you see, Karina Young is here, here, and here. So probably in these three activities, and this activity is this one, and this one. In these three activities, Karina Young is involved. No, this, and this. So naturally, her time is distributed accordingly. Her consumption of time by Karina Young would be shown here. She is committed for these many hours on these days. Luis de Souza is committed for these many hours on these days. Other resources like OSS Architect has a commitment on these days, and so on. So this is a beautiful way. Using a Gantt chart, using a software, we can make many things easier. Everything could be done at one place. We don't use, maybe I don't need to open an Excel sheet to do these calculations, but this is done by that software. But this is just one example how the things are happening during the execution. Okay. This is one representation, the same Gantt chart we have created. If we eliminate all the bars and activities from there, and we only show the major milestones are shown like a diamond. So these are the major milestones, and these are linked through various relationships. So these are the milestones, only the milestone chart. Or you could show some clients may be interested, but some stakeholders may be interested in looking at the network diagram view. So they could see something like this. Then we have the concept of resource optimization. And in the next slide, we are talking about schedule compression techniques. So these four techniques are very important. Resource optimization, we have two techniques, two methods. One is called smoothing and one is called leveling. Now let me very briefly explain it to you in a layman language. When do we smoothen it out? Okay. We adjust the activities within the predefined resource limits within free and total floats. What we are trying to do is we see that on some days of the project, the commitment of resources is too high, and on some days it is too low. You have to understand my point. I don't want to. Okay, let me give it like an example to you. For example, I have got my resources, 3 resources are required. Let's call them X, Y, and Z resources. So this is the graph for my X resources, and say it is an 11-day project, and these are about say 10 people. A maximum 10 people are required at any point in time. On first day of the project, we need only 2. Second day of the project, we need 4. On third day of the project, I'm sorry, I'm unable to do that. Let me remove that and do it in more professional manner. Okay. Let's say I have to change the color of this thing. Okay, let's say this is my one resource I'm talking about, and I have this resource utilization to be this much. First day, second day, this much. Third day, maybe this much. And then I don't have this required for this day, not required for this day. And then I require him for 2 days. And then I require him for 1 day to be 10 people. And then maybe 1 person on this day. Now you see that demand, the requirement, the resource requirement for this X resource, this is the, sorry. This is the X resource, right? The resource requirement on 1 day, day 1, 2, 3, 4, 5, so on. So this requirement might be, 2 days here, 2 persons here, 4 persons here, and maybe 6 persons here, 0 here, again 0 here. Here we have got again 2 people. Here I require 10 people. Here I require 1.
So
And
Suhail,
here I require again 4. So you see what I am trying to prove to you on each day we need a varied number of resources.
so
So
smoothing.
for example, the maximum number of X you require is 10 people. Maximum number of Y resource you require 8 people, and maximum number of Z resource you require is say 12 people. So how many people will you hire for this project? These are the 3 types of resources.
I can hire the 8 people.
You can hire?
What 8 people as long as I distribute the workload on day 4.
Very good. That is what I'm pointing. It is not very right to hire 10 X's 8Y and 12Z, because if I can show you like that, this is my, if I hire all of these people, then for 11 days, I need 10 people only in the X category. So 10 into 11, say there are 10 days, I need 100 people to pay. But actually, how many people are actually being utilized on that is 4 plus 1, 5, 6, 7, 17, 18, 19. 19 people are required. You are paying, 19 people are required to be paid. I mean, 19 days. 19 days compared to 100 days. We are paying 81 days extra salary to these people if we hire the highest number. That is obnoxious. That is obnoxious. I have to bring down the level. For example, I should bring it down to this level. I should not hire more than 4 people. Now that there is a problem, what about the third day of the project where I needed 2 extra people? So what I do is I will try to extend this job in such a manner that because on the next 2 days there is no requirement for X, so I can reduce this resource to 4 and elongate this activity to the next day as if this can be done within 4 resources. Similarly, I can do the similar exercise by cutting out this portion of work and this portion of work and fitting it into this area, this area, this area, and this area. I think these are more areas available in which I can fit in those resources, but I can limit my resources to 4. So my wastage will be reduced. When I was hiring 10 people for 10 days, my resource count was 100. Now it is just 40. So if my requirement is 19 or 20, I am still wasting some resource, but it has been reduced drastically. I have brought it down from 100 to just 40. I could even reduce it further. If I am more economical, I would say let us, uh, I mean, let us put it to the level of, say, 3. So in that case, I will have just 3. That means 30 resources as compared to 19. Our wastage is only 11 resource days, right? I think this is even much better rather than hiring this much people. That is exactly what it is saying, that adjust the activities within the predefined resource limits and within the free and total float. If you have any float, try to make use of that. If you have got, extra, time, free open spaces available where these resources are not required, let us try to push them in that side. I hope you got this point. This is called smoothing. I am smoothing. Leveling means adjusting your start and finish dates based on resource constraint. Goal is to balance the demand for resources with available supply. When shared or critically required resources have limited availability or are over allocated, this will affect the critical path. Smoothing is when without spending a single extra penny, we are kind of economizing by remaining within the existing time frame. If the time frame is going to be impacted, especially the critical activities, that would be called leveling. Crashing is where you are making use of available floats and areas which are free, where no work is going on, you can do that work during that period without spending extra money. In leveling, we may have to change our critical path. It may impact your plan. So these are two resource optimization techniques. Let me clear it all up for you. Okay. Then we can move on to schedule compression. Again, we have got two techniques for that. One technique to compress the schedule is called fast tracking. Fast tracking is we can achieve the project in lesser time by creating more parallelism. I mean, by changing the relationship from finish to start, or to start to finish, or from finish to finish, that would create an overlap. By uh, adding the lead on various activities, naturally that will create an overlap. Or by creating overlaps between two phases of the project, that will also reduce the time of the project. So schedule can be compressed by these intelligent techniques. Where there is space, you compress your schedule without any extra cost. You will be able to perform your work. But that is a fast tracking. What if you are in an emergency situation? You have already been delayed by 10 days, and you have been given an ultimatum that if you do not complete the project tomorrow night, you will be fired. So how can you do 10 days job in one day? How can you complete the 10 days work in one day? That is called crashing. Crashing means by hook or by crook. Put more resources on it, put more money on it, do anything, but do it day and night, overtime, whatever. You just have one day. Do 10 days job in one day. Maybe you have to overload the resources. Maybe you have to ask for external help to do that job. But in one day, you will have to complete everything. This is called crashing. This may cost you dearly, but it will save your repo. So that is a difference between fast track and crashing. Crashing requires a lot of increased cost, whereas in fast tracking, I believe there is not that much increased cost, but basically we are increasing the risk there. The things which you are very carefully doing one after the other, now we are sacrificing care for the sake of overlap. If something goes wrong, then we will suffer. Then we will have increased cost. But in crashing, there definitely is additional cost. There is overtime, there are additional resources, there are other things. So we are paying extra money for that. Right. Finally, once everything has been done, everything has been adjusted, compressions have been done, you have optimized the resources, and now your schedule is ready to be presented to the big boss as if they can approve it, they can baseline it. But remember, be careful. After the schedule is baseline, you will have absolutely no authority to change anything in the schedule without the permission of your boss. But this is necessary. This is for your own protection, because if you don't get it baseline, the blame is always going to be coming back to you because you have never baselined it. Once you baseline it, the ball is now in the court of your boss. If there is something to be changed and he is not allowing it, that is his problem. Right? So naturally, this is a bargain. And this is a necessary element. We need to have all the three baseline, the schedule, the scope, the schedule, and the cost. They all have to be baseline as if we can move on to execution. We can't go to execution without having these baselines approved. Right. After this, we'll enter into the agile scheduling. And I suppose we are already done with the time, and I should not be starting a new topic here, although it is still scheduling. But we will be now talking about the scheduling in agile projects. Therefore, let us spend it for the next class, which probably is on Monday.
Yes.
Yep.
Right. The same old time, we will meet again. And so let's conclude this class. Any questions at the end of it?
No.
All
Nope.
fine?
All fine.
Okay, then thank you very much for your company today. I think it was much better interaction. You people really participated, and it was really helpful for me to understand where you are and where I am. That is really very good. Thank you very much, and take care, and see you again tomorrow, Monday. Thank you and bye.
Have a nice weekend, Suhail.
Thank you.
Yeah.
Take care. Bye bye.
Bye.